Section 1.2, Real Number and Basic Arithmetic Operation, Part 1. In this video, we'll study different sets of numbers. We'll talk about algebraic operation and expression and how to compute with fractions. The other subsection 1.2 will be studied in another video. So we start with the main sets of numbers. We have the natural number denoted by capital N, numbers 1, 2, 3, 4, and so on. When we add 0, we get a whole number, and when we take natural numbers, 0 and negative number, these are called integers, and the set is denoted by Z. It's not denoted by capital I because we'll need capital I for another set. So Z is the set of integers. Then when we divide two integers, when we divide 1 by 2, it's not an integer. The result is not an integer. It's 0.5. So we define a larger set called rational numbers. Rational numbers. A number is said to be a rational number if it's the ratio of two integers. It's A over B, where A and B, two integers. So these are some examples of rational numbers. 10,000 over 47 is a rational number since it's the ratio of two integers. 2 over 21 is a rational number. 3 is a rational number. So rational number is a larger set containing both integers and natural numbers. All real number can be represented on a line with 0 here, positive numbers on the right, and negative numbers on the left. And here we have two arrows to say that it's infinite in both sides, to the right and to the left. What are real numbers? So real numbers, these are some examples of real numbers. So it contains natural numbers, integers, -2, rational numbers, -5 over 3, and radicals, -square root of 7, special numbers, pi. All these are called real numbers. Some real numbers are not rational numbers, like -square root of 7 and pi. These two elements, we'll see that they are not in Q. They are not rational. They are not ratios of two integers. So these two elements are not rationals. The elements which are not rational are called irrational. Irrational. So real numbers, the set of real numbers is formed by rational numbers and irrational numbers. The irrational numbers are the elements which are real and which doesn't belong to Q, which is the set of rational numbers. The Example of irrational numbers are minus square root of 7, square root of 2, pi, and so on. So we can represent these sets following. So we have natural numbers. When we add 0, we get a larger set called whole numbers. So natural numbers denoted by capital N. Whole numbers by W. Integers, when we add negative, minus 1, negative 2, negative 3, these integers denoted by Z. The ratio of two integers give me a rational number denoted by Q. We have some numbers which are not rational, and these are called irrational. These are some examples. And all these numbers form a large set called real numbers and denoted by R. This is not, of course, the larger set of number, because there are, for example, other type of numbers like imaginary number, complex number, and so on, which will be studied in next lectures. So here we can see that natural numbers is a subset of whole numbers, which is a subset of integers, which is a subset of rational numbers, which is a subset of real numbers. So this is natural, whole number, integer, rational, and real. And we have also irrational numbers. So these are the different subsets of real numbers. Of course, the union of rational and irrational give me real numbers, and there is no numbers which are at the same time rational and irrational. Okay, so Q inter I is empty set. These two sets are disjoint. There is no intersection between rational and irrational. There is no number which is at the same time rational and irrational. So, example 1, determine whether the statements are true or false. Every integer is a rational number. So this statement is true. Why it is true? If we take an element in Z, an integer, a integer, does A belongs to Q, to rational numbers? To prove this, we must write A as a ratio of an integer of two integers. But this can be done just by writing that A is A over 1. So A over 1 equals to A. So A can be written as a ratio of two integers. So since it is a ratio of two integers, so it is a rational number. So any integer, every integer is a rational number. So Z is a subset of Q. Now, section B. The number pi is a rational number because pi equals 22 over 7. So we know that 22 over 7 is a rational number since it's the ratio of two integers. So this is It's known that this is a rational number. The question is pi equal to 22 over 7. To know it, let us try to check using a calculator the value of pi and the value of 22 over 7. So using a calculator, we can see that the value given by the calculator for pi is 3.14592 and so on. Whether the value given calculated for 22 over 7 is 3.142857 and so on. So we can see clearly that pi is definitely not equal to 22 over 7. 22 over 7 is just an approximation of pi. So this is false. Pi is not equal to 22 over 7. And this is false. Pi is not a rational number. And we have already said that Q inter I is empty set. So no number is rational and irrational at the same time. We'll see later in this lecture how to characterize a rational number and how to characterize irrational numbers. Decimal representation of real number. كتابة العشرية using باستخدام الفاصلة. So every real number can be written in decimal rotation. These are some examples. 3 over 4 can be written as 0.75. 7 over 3 can be written as 2.3333. Square root of 2, this is the decimal representation of square root of 2. And this is the decimal representation of pi. And this representation will help us to state whether a number is rational or irrational. How? So we have here, we can see 3 types of decimal representation. This is the first type. This is called a terminating decimal number. Why is it terminating? Because 3 over 5 is 0.75. There is no numbers after, there is no digits after 5. Okay? If you divide 3 over 5, 0, 0, 13 over 4, 7, 7 times 4, 28, 2, 0, 20 over 4 is 5, 5 by 4, 20. So here, the remainder is 0, so we are done. We terminate the division. Okay, so this is called a terminating decimal number. This is the second type. What's the property of this type? You see here, we have a repetition, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3. So this is called repeating decimal number. And this can be represented by 2.3 خط فوق 3. This means that we repeat 3. And these are example of the third type. So here, this representation is not terminating. Is it repeating? No, because 4, 1, 4, 2, 1, 3, 5, 6, 2, 3, 7, 3, 0, 9. So no repetition. So neither terminating nor repeating. لا terminating ولا repeating، لا هو من النوع الأول ولا هو من النوع الثاني. Why this is important? It's important since we can say that the two first types, so if the decimal representation is terminating or if it is repeating, so these are rational numbers. لكن if we have a number of the third type, neither terminating nor repeating, this is an irrational number. So rational numbers has a terminating or repeating decimal representation, whereas irrational numbers are neither terminating nor repeating. Then square root of 2 and pi are two examples of irrational numbers. Whereas 3 over 4 is a rational number and 7 over 3 is a rational number. So I repeat it. These are examples of terminating and these are examples of repeating decimals. The repetition دوري ممكن يجي بعدين مش من أول عشر، يجي بعدين. إذا هنا مثلا in this example, where is the repetition? This is the repetition, 5, 4. Then how to write it? We can write it 3.754 سطر على 5, 4. So this is the repetition in this case. Okay, and as I said, rational numbers are either repeating or terminating. Irrational numbers are neither repeating nor terminating. Let us see an example. In this column, we have a list of numbers. We try to state each number to which sets it belongs. So -3 is not a whole number. So it's asking to put a cross if it's an element of the set. It is an integer, yes. So since it is an integer, it is a rational number. Since it is a rational number, it is not an irrational, and it is a real number. 22 over 7, this is quotient of two integers. So it is a rational number. So it is not an irrational number. 22 over 7 is 3.14, so on. So it is not an integer. It is not a whole number. It is a real number. هنا قلنا ممكن نعرفها decimal representation. كم decimal representation of 22 over 7? Here, 22 over 7 using a calculator, we can see that it is 3.142857 142857 14 and so on. So where is the repetition here? The repetition is all this. So it is equal to 3.142857. So it is a rational number. Minus pi. So we all have already seen pi. This is pi. So here we can see clearly that it is not terminating and there is no repetition. We cannot find the repetition. Even we go here several decimals. So pi is not a rational number, it is an irrational number, and it is a real number. 3.14, which is not pi. I recall, 3.14 is an approximation of pi, but it's not pi. So here it is a terminating decimal representation. We have no ellipses here. So this is a rational number. It is not an irrational. So it is real. It's clear that it's not an integer. It's not a whole number. 2.718281. So هذا neither terminating nor repeating. Then it's an irrational number. It's a real number. 1331 over 11. So it's clear that it's a rational number, quotient of two integers. It's real. It's not irrational. السؤال is it an integer؟ حتى نعرف we have to check the decimal representation. لما نحسب this quotient using a calculator, we find it's 121. So be careful. شكله يقول it's a quotient, it isn't an integer, it isn't a natural number. لكن بالحقيقة إذا نحسبها النتيجة هي 121. So this number is both an integer and a whole number. 110.916 and repetition. This is a repeating. This is a repeating decimal representation. So it is a rational number. It is a real number. It's not irrational, and it's not an integer. ماهوش عدد صحيح. It's not a whole number. Square root of 5625. Here also. أول فكرة إنه square root, so it's an irrational number. But be careful. أحسن مثال square root of 4. كم square root of 4? Square root of 4 is 2. So square root of 4 is a natural number, is an integer, it's a rational number, but it's not an irrational number. So what about square root of 5625? So using a calculator, this is equal to 75. So this is a whole number, it's an integer, it's not irrational, it's rational, and it's a real number. Now we deal with operations, algebraic operation, عمليات الجبرية. So what are the basic algebraic operation? We have addition, الجمع, plus. The operation is called addition, عملية اسمها الجمع. The multiplication, الضرب, times. The subtraction, الطرح, minus. الإشارة اسمها minus. And the division, divided by. So these are the four basic algebraic operation. Now, in mathematics, we use what we call a variable, متغير. A variable means that it can take different values, several values. Okay? على عكس ال constant, ثابت. 5 is a constant, قيمتها ثابتة. A variable ممكن تاخذ can takes several values. So usually we represent it using a letter or symbol, X or Y or Z, to denote a variable. Okay? So now what do we call an algebraic expression? Algebraic expression is not an equation. فيه المعادلة plus 1 equal 5 minus x. This is called equation. It's equality, مساواة, between two quantities. And each of these quantities are called algebraic expression. So what's an algebraic expression? Algebraic expression, these are some examples, is formed by variables, numbers, and basic operations. Okay, so if we combine variables, numbers, and operations, we get what we call an algebraic expression. X plus y is an algebraic expression. تعبير جبري. Pi plus t over s minus 1 is an algebraic expression. 2x minus yz minus 5 is an algebraic expression. So, خلينا نشوف the main properties of basic algebraic operation. نبدأ بالجمع, the sum of real numbers, x plus y. So, the sum of two real numbers is a commutative, تبديلية, which means that the order is not important. That a plus b equal b plus a. That 1 plus 5 equals 5 plus 1. الترتيب مش مهم في الجمع. It is commutative, تبديلي. It's also associative, تجميعي. What does it mean? It means that when we have the sum of three real numbers, we can start by adding the first two and then we add the third, or we add the last two, ثاني والثالث, وبعدين نضيف لهم الأول. Okay? إذا الأقواس ممكن أحركهم. So, addition is commutative, addition is associative. We can start by adding these two, or we can start by adding these two numbers. What about the product? A times B. هذه اسمها times. A times B. A ضرب B. Or A multiplied by B. A and B are called factors of the product. The multiplication is also commutative. ترتيب مش مهم في الضرب. AB equal BA. لما ما نحطوا رمز نقصد ضرب. So here we have multiplication. لما ما في علامة وتكون واضحة, A, B is A times B. And AB equal BA, so it is commutative. It's like the sum of real number, it's also associative. يعني الأقواس مش مهمين. نضرب A في B أول بعدين نضرب في C. أو نضرب B في C أول وبعدين نضرب في A, we get the same result. This is an illustration. We can compute this product without using a calculator, by using only the properties of the multiplication. مثلا هنا عندنا 2 في 129 في 5 ممكن أبدل مكان ال 2 و 129. I commute 3 times 2 times 5 because it is commutative. الحين عندي ضرب ثلاثة، نضرب 2 ونتيجتهم نضربها في الثالث. إيش نبدأ؟ ممكن نقول نبدأ بهذا من 2 because it is associative. But 2 times 5 is 10. And 129 by 10 is 1290. So thanks to the properties of multiplication, commutative and associative, we can easily calculate this product. Okay? So this is just to illustrate the properties of the multiplication. We have an important property of multiplication, which is the zero factor property, which is used, for example, to solve equations. شو تقول هذه zero factor property؟ تقول if the product of two factors equals 0, if x times y equals 0, then لازم يا إما x 0 أو y 0 أو الاثنين 0. So if the product is 0, this means that at least one of the factors equals 0. نشوف المثال. Let x be a real number. Assume that x minus 1 times x plus 1 equals 0. What are the possible values of x? هنا عندنا معادلة نحب نحلها. بما أنه عندنا product equals 0، إيش معناها؟ Using the zero factor property، يا إما ال first factor اللي هو x minus 1 equals 0, or the second factor اللي هو x plus 1 equals 0. And then we easily see here that x must be equal to 1, or here x equals minus 1. So the possible values of x which make this expression equals to 0 are x equal 1 or x equal minus 1 using the zero factor property. Another important property of multiplication is that it is distributive, توزيعية على الجمع. So here in this expression we have multiplication and we have addition. So we have two different operations. عن الاديشن داخل القوس وعن المالتيبليكيشن برا القوس. إذا في الحالة هذه ممكن نحذف الأقواس. I can remove parentheses. كيف؟ لازم أوزع ال A على كل اللي داخل. هنا عندنا بلاس داخل القوس، multiplication outside. So I can remove the parentheses by distributing C على all terms inside the parentheses. الأولى تعطيني A في B plus A في C. الثانية تعطيني AC plus BC. So we multiply all the terms inside the parentheses by C here. It's a right distribution. Here we multiply all terms inside the parentheses by A. So it's a left distributive. هنا ضرب the multiplication of real numbers since it's commutative left to right are same. الترتيب مش مهم. لكن بعض الأحيان تفرق left and right. So as an application, example 6, remove أحذف the parentheses الأقواس from each of the following algebraic expression. So here we have a multiplication 5 times x plus 4. To remove parentheses, we distribute. So 5 times x gives 5x, and 5 times 4 gives plus 20. And we have no more parentheses. We distribute it. Here the same, we can't distribute since we have multiplication outside, addition inside. First تعطيني 2x plus x times x here x square, and I removed the parentheses. Here the same, I can distribute. So 2x times 3x, 2 times 3 6, x times x square, plus 2x times 2, 2 في 2 4 x. Then we distribute the 3. 3 times 3x plus 3 times 3, 9x, and 3 times 2 plus 6. And we see we can simplify more by adding these like terms. 4x plus 9x, actually 4 and 9, 13x plus 6. But be careful, we distribute only the multiplication over the addition. إذا عندي A times B times C, here we have only multiplication, so we don't distribute. This is false. Okay, here it is A, B, C. نعملوا A في B, A في C. Be careful. We don't distribute multiplication على multiplication. We distribute only multiplication على addition. نفس الشيء مثلا شو أقصد بهذا مثال؟ إذا عندنا 2 في 3 في 4 هنا ما نوزع. لا. أوكي؟ هنا فقط تحسب 3 في 4 ب 12 في 2 ب 24. أوكي؟ إذا نوزع خطأ. إيش معناها نوزع؟ إذا نكتب هذا لا يساوي 2 في 3 في 2 في 4. لا. إذا هنا التوزيع لا ممنوع لأنه ضرب على ضرب. نوزع فقط ضرب على الجمع. نفس الشيء ما نوزع جمع على جمع. إذا عندي 1 زائد 2 زائد 3 ما أجي أقولها هنا أوزع. تصير 1 زائد 2 1 زائد 3. لا. هنا عادي ناخذ الأقواس يعني نقول 1 زائد 5 6. إذا التوزيع فقط multiplication over addition. Okay, and we have the two operations, addition inside parentheses and multiplication outside. Here I can distribute. Properties of negatives. Be careful. الإشارات مصدر أخطاء كثيرة. معظم أخطاء الطلاب في الإشارات. إذن ركزوا. عندنا ماينس أمام قوس شو نسوي؟ نغير كل الإشارات للداخل. We switch all signs inside parentheses. So minus في minus A تعطينا A. minus 1 في A minus plus minus 1 في A minus A. minus A في minus B minus في minus plus A في B. minus A في B هي A في minus B هي minus AB. ممكن نكتبها minus AB. نشيل الأقواس. Evaluate. So minus 2 times 3. عندنا minus في plus minus. نبدأ نضرب بالإشارات. We multiply signs first. Then we multiply numbers. 2 في 3, 6. minus 2 في minus 3, minus في minus plus, 2 times 3, 6. Negative 2 times 3 تعطيني negative, and 2 times 3 is 6. Negative 5 equals 5. Here, have a look to E and F. Are they equal or are they different? خليني أطرح السؤال بطريقة ثانية. هل الأقواس مهمة؟ هل تلعب دور؟ Or is it just للزينة as decoration? ديكور. جواب: الأقواس مهمة في الرياضيات. مو فقط ديكور. شو الفرق بين هذه وهذه؟ minus 2 سكوير ايش معناها؟ معناها كأني عملت minus 2 في minus 2. minus 2 في minus 2 اللي هي 4. بما معناه وراح نشوفوها بعدين في next section. عندي parenthesis وعندي قوة أوزعها على كل اللي داخل. نفس اللي قلنا على الضرب، قوة مستمدة من الضرب إذا تتوزع. لكن في المثال هذا there is no parenthesis. Here no parenthesis. إيش معناها؟ معناها square at 2 only. It's negative 2 squared. إذا negative ما عليها تربيع 2 squared هي 4. So هذه equals my negative 4 وهذه equal 4. So be careful. The parentheses are important. They play an important role usually in algebraic expression. G عندنا minus واحدة في minus plus في minus minus. عندنا 2 في 3 6 في 4 24. H عندنا minus في minus plus 5 في 2 10. نضرب هذا الاثنين أول associative. نضرب هذا الاثنين من بعد. minus في minus plus 3 في 4 12. تعطيني 120. So these are some properties of negatives. Be careful when you deal with parentheses. Distribution. نفس ما قلنا على الجمع is valid for subtraction. So we can distribute multiplication over subtraction. AB minus AC. AC minus BC. So I can distribute. I can remove parentheses. So here we will distribute 2 times 2W, that you need 4W, 2 times minus 5, minus 3 plus minus, 2 times 5, 10. Here also I can distribute 2x times x, that you need 2x في x, x square, 2x times minus 7, minus 3 plus minus, 2 times 7, 14x, minus 3 times x minus 3x, minus 3 times minus 7, minus 3 minus plus, 3 times 7, 21, and I can simplify a bit more. These are two like terms. and تعطيني minus 17x plus 21. Using the fact that we distribute multiplication over subtraction. Remember that when a parenthesis is preceded by minus sign, we remove the parenthesis by changing all the signs inside the parenthesis. مثلا هنا عندنا minus sign before the parenthesis. then هنا ما نوزع لأنه مش ضرب، هنا طرح. then we don't distribute. Okay? We have minus. We don't have multiplication. إذا 4x لسه ما جاء دورها تنزل. نبدأ نشيل الأقواس. عندنا minus أمام أقواس نسوي. We remove parentheses and we change all signs inside. غير كل الإشارات للداخل. إذا 3 كانت positive تصير negative. والماينس هذه كانت negative تصير plus. بعدين ممكن نبسط 4x و 4x 8x minus 3. هنا the same. We have minus in front of the parenthesis. إذا هذه لسه دورها عندنا minus نسوي نغير كل الإشارات. كانت plus تصير minus. كانت plus تصير minus. بعد we add like terms. Minus 8x minus 3. So these are examples where we have minus and we have parentheses. So be careful. All signs was changed. All signs are changed. Why? Because I have minus أمام الأقواس. Same question, simplify, remove parentheses. هنا ايش عندنا؟ ضرب ولا طرح ولا جمع؟ هنا عندنا ضرب. عندنا multiplication لأنه ما حط ولا شيء. لأن هنا ايش نسوي؟ راح نوزع هذا. لأن لما نوزع 5y قلنا لسه ما جاء دورها تبقى. بعدين عندي minus 5 في minus x. minus في minus plus. 5 في x 5x. الثانية minus 5 في minus y. minus في minus plus. 5 في y 5y. I have two terms in y. So 10y plus 5x. Here I have minus. ايش تعمل الماينس؟ 5y waiting عندنا minus. So هذه تصير plus وهذه تصير minus. إذا تعطيني 5y minus y 4y plus x. This is very very important, these properties. Be careful. أي خطأ في الإشارة الكل راح يصير خطأ. Fractions الكسور. قلنا fractions منين جاوا الفراكشنز؟ الفراكشنز جاوا من قسمة الأعداد الصحيحة. When we divide two integer, we get a rational number. A over B. So we say A over B or A divided by B. And this is called a fraction. صفر في القسمة. لما عندنا صفر في البسط في النيميريتور 0 over A is always 0. لما عندنا 0 في المقام in the denominator it is undefined. So be careful, no division by 0. It's forbidden to divide by 0. ممنوع القسمة على صفر. Don't forget this. How to check equivalent fractions? So we said that two fractions a over d and c over d are equal if AD minus BC equals 0. أعطيكم مثال مثلا 15 over 9 is equal to 20 over 12. كيف عرفنا؟ لما نضرب 15 في 12 كم نلقى؟ 180. ولما نضرب 20 في 9 نلقى 180. So these two products are equal. So these two fractions are equal. هذا يمكننا من cancellation التبسيط. How to cancel fractions. To cancel fractions, be careful. We can cancel only when we have multiplication or division. When we have multiplication by the same factor, we can cancel it. When we have division by same factor in the numerator and denominator, we can cancel it. مثال هنا نرجع للمثال هذا 15 over 9. ال 15 ممكن نكتبها 5 times 3 وال 9 3 times 3, so I can cancel 5 over 3. 20 over 12, I can also cancel here since 20 is 5 times 4 and 12 is 3 times 4. So we have common factor in numerator and denominator. We can cancel and we get 5 over 3. And you see that these two fractions are both equal to 5 over 3. So this is another way to check whether two fractions are equal. قلنا هذا ممكن فقط المالتيبليكيشن ولا الديفيجن. بما معناه إذا عندنا مثلا 3 plus 2 over 3 plus 1 هنا عندنا جمع. إذا نبسط عندنا 3 common في النيميريتور والدينومينيتور ايش تعطيني؟ تعطيني شبقى لي 2 over 1 يعني 2. السؤال هل 3 plus 2 over 3 plus 1 equal 2? Of course not. لا. يعني 3 plus 2 over 3 plus 1 هي 5 over 4. It's not 2. Okay? Be careful. No cancellation when we have addition. Okay? نفس الشيء when we have subtraction 3 minus 2 over 3 minus 1. If we cancel 3 تبقى لي minus 2 over minus 1 يعني 2. لكن هل 3 minus 2 over 3 minus 1 equal 2؟ لا. هي equal كم؟ نص. So it's different. وين الخطأ؟ إنه we cancel it بسطنا وعنا طرح ممنوع. Okay? This is very important. Another example. Determine whether 3 square root of 2 over 3 pi plus 1 equals square root of 2 over pi plus 1. Is it true? Yes, because here we have 3 and here we have 3. So we can cancel and we get square root of 2 over pi plus 1. The same. You agree? Of course not. Be careful. This is false. Why? Because I have addition here. So no cancellation. ممنوع التبسيط. Okay? ما نبسط 3 هنا والثلاثة هنا. ما نقدر نبسط لأنه عندنا جمع في المقام. لأن التبسيط ممنوع. حتى نتأكد إذا نضرب هذه في هذه ايش تعطيني؟ 3 square root of 2 times pi plus 1 إذا لازم نوزع distribute. والثانية 3 باي plus 1 times square root of 2. نحطوا الأقواس، هذا كله راح نضربه square root of 2. We multiply all this quantity by square root of 2. So here also we distribute, starting 3 pi square root of 2 plus square root of 2. إذا هذا وهذا are the same. لكن هذا 3 square root of 2 square root of 2 they are different. So this is not true. This is false. These two quantities are different. ليش different؟ لأنه هنا ممنوع التبسيط. Okay. Operation on fractions. For fractions, we can add, we can subtract, we can multiply, we can divide. الأسهل هي multiplication. أسهل من addition of fractions. ليش؟ لأنه to add two fractions we must have the same denominator. We can add only if the two fractions have the same denominator. بما معناه ممكن فقط نجمع لما عن 1 over 3 plus 7 over 3. Here we have the same denominator, we can add, and the result will share the same denominator, the two terms. وفوق we add the numerators. نجمع البسوط ونقسم على المقام المشترك. هذه طريقة جمع البسوط. السؤال إذا denominator are different B and D نسوي هنا ما عندناش خيار إلا توحيد المقامات. Reduce to the same denominator. So if I have half plus 2 over 3, the denominators are different. لازم نوحد المقامات. كيف نوحد المقامات؟ نضرب المقام هذا في 3 ونضرب المقام هذا في 2. لكن to keep the same value of the quotient إذا ضربنا المقام 3 لازم نضرب البسط في 3. If we multiplied here by 2 in the denominator, we must multiply the numerator by 2. Then what we get? 3 times 1, 3 over 6. وهذه 2 times 2, 4 over 6. Now we have the same denominator. We can add. The denominator will be 6. We add the numerators. 3 plus 4, 7. So this is how to add two fractions with different denominators. Opposite fractions عندي minus نكتبه في النص in the middle or in the numerator or in the denominator, so it's the same thing. Okay. فقط لما يكون minus على الكل ما معناه لأن هذا يعطينا الطرح نفس الجمع. إذا عندي same denominator I can subtract. وإذا عندي different denominators لازم نوحد المقامات وبعدين أطرح البسط. بالنسبة للريسيبروكال، reciprocal يعني المقلوب، يعني تقلب اللي كان مقام طلع لفوق للبسط واللي كان بسط صار في المقام. So reciprocal, the denominator becomes the numerator and the numerator is the new denominator. We switch the places. For the division, to divide two fractions, لازم we transform the division as write it as a multiplication. But multiplication of what? Of the first fraction a over b multiplied by the reciprocal of the second. مقلوب الثاني اللي هو D over C. وبعدين في الضرب we multiply A في D numerators and we multiply B في C the denominators. Let us see an example how to perform operation on quotient. Perform the indicated operation. So half plus 3 over 5, we don't have same denominator, we must reduce to same denominator. So we multiply here by 5, we multiply here by 2, up and down, up and down. 5 times 1, 5 over 10, plus 3 times 2, 6 over 10, so we get 11 over 10. Same thing here, we have subtraction, different denominators, so we reduce same denominator. Multiply by 5 here, by 2, up and down, up and down. 5 times 7, 35 over 10, minus 3 times 2, 6 over 10. Denominator common 10, 35 minus 6, 20. In this example, it's a product, so we multiply signs, minus v plus minus, and we multiply numerators, 1 times 3 over 6 times 8. But here we can't simplify, it's better to simplify before calculating, and 3 or 6, you can simplify by 3, and that for 2. And that in minus 4, 1, تحت 2 times 8, 60. Here also, we have minus times minus plus. We have a multiplication, so we can simplify 3 و 3 تمشي 5 و 5 تروح ما بقى شيء هنا راحوا كل الأعداد لما يروحوا كل الأعداد يعني يبقى. This is a division. قلنا division لازم نحولها إلى multiplication. كيف أحولها multiplication؟ 11 over 5 times مقلوب 4 over 3 يعني 3 over 4 reciprocal. And that in 11 times 3, 33, 5 times 4, 20. And here there is no simplification, no cancellation. This is also division, so we transform it as a multiplication by the reciprocal, minus 6 over 5. Here I have minus v minus plus. Here we can simplify. 2, 2 v 2, 4, 1 v 5, 5. And this is the result. Here same thing. So addition, different denominator, so we reduce the same denominator. So we'll multiply here by 2, and we multiply here by 3. 3, here 2. So we get 2 over 6 plus 3 over 6. So 6 is the common denominator. And we add 2 plus 3, and the result is 5 over 6. Same thing here. We multiply by 3. We multiply by 2. We get 3 over 6 minus 2 over 6, which gives 1 over 6. Here also, we don't have the same denominator. We reduce same denominator. So if you multiply 9 by 3, we get 27. So it's fine to multiply by 3 over 3, the first quotient, the first fraction. So we get 3 over 27 minus 2 over 27, which gives 1 over 27. Here we have a multiplication. We can simplify 7, 14, 2. 2 times 7. So 2 times 2 is 4 over 3. Same thing here. 2. إشارات minus v plus minus. 2 times 2, 4 over 3. في المثال هذا كيف نطرح integer minus fraction؟ لكن قلنا each integer is a rational number. So each integer can be written as a fraction with denominator 1. So هذا هو 5/1 minus 1/5. Different denominator. إذا نضرب هذا 5/5 وهذا. So the common denominator is 25/5 minus 1/5. So 24/5. هذه فيها A. كيف نحلها؟ ما نصعبها وما نتفلسف. We have A or 5 or 7 or any number. نطبق القوانين متاعي وبعدين نشوف شو يصير. ايش عندي هنا؟ عندي division. ايش قلنا على division؟ We said that the division, we transform the division to a multiplication. كيف نصير multiplication؟ A تبقى الأولى وناخذ the reciprocal of the second fraction. إذا مقلوب 1/3 times, so we get 3A. So this is equal to 3. الثانية الحين 1/3 divided by A. شو تقول القانون؟ It says that we keep the first fraction and we multiply by the reciprocal of the second. 1/A. ليش؟ لأنه ال A هي A/1. Then we take the reciprocal. يصير ال 1 هو في النيوميريتور وال A في الدينومينيتور. Then we multiply 1 by 1 هي 1 و 3 times A هي 3A. So this gives 1/3A. هذه easy. 14 و7 تروح. minus في minus plus. 2 في 2 4. 1 في 3 3. هذه division. إذا تصير multiplication 3/40 ونضرب 6/90. Here we can simplify. سهل علينا. دائما if you have cancellation أبدأ بها. عندي 2/14 يعني تبقى 7. 1 في 3 3 و7 في 7 49. This is a division. A division تصير multiplication. So times what؟ نقلب هذا. تصير minus. ما نقلب الإشارة نقلب فقط مراكز العدد. minus 2/1. minus في minus plus. 1 في 2 2. 3 في 1 3. هنا كيف نضرب؟ هذا integer وهذا fraction. نفس الشيء. قلنا be careful مش نضربهم كلهم في 3. false. لازم نكتبه as a fraction حتى ما نحط. Now we have classical product of two fractions. We multiply numerators and we multiply the denominator. We obtain 15/7. البسط في البسط المقام في المقام هذا الفرق. And we are done with the first part of section 1.2. We'll see the second part in another video. Thank you for your